Okay, today we're going to talk about graphing linear inequalities part 2. All right, remember that a linear inequality divides the coordinate plane into two halves by a boundary line where one half represents the solutions of the inequality. The boundary line is dashed for less than or greater than symbols, and it's solid for less than or equal to, greater than or equal to symbols. So I've added an extra step for what we need to do in order to graph this. All right, note before, we already know how to plot the y-intercept and the slope based off of slope-intercept form. So the first step is we need to turn these equations that look like standard form into slope-intercept form. All right, and then determine whether the line will be dashed or solid. Graph the boundary line, determine the shading, and then check the solutions. All right, so let's say, for example, we have x plus y is less than negative 4. All right, note that the equation without the inequality would be x plus y equals negative 4. So if we're turning this into slope-intercept form, there are a couple of ways to do this, but the main thing is to remember to find the slope. That's negative a divided by b, and to find our y-intercept, we take our c and divide it by our b. And let's realize what our a, b, and c is in this situation. Remember, standard form is 8x plus by equals c. And since in this problem here, x and y look to be alone, there's only one of them. So our a is 1, our b is 1, and our c is negative 4. So we're just going to plug that into these formulas. Negative 1 over 1, which is negative 1, and then c, negative 4 over 1, which is negative 4. So our slope appears to be negative 1, and our y-intercept, negative 4. All right? And from here, we did not divide by a negative number, so we get to keep this symbol right here. All right? And we're just going to, we've turned it into slope-intercept form, right? That's checked off. And now we need to determine whether it's going to be dashed or solid. Well, it's less than, strictly less than. And we said that we have a dashed line with less than or greater than. So this is going to be a dashed line. And now we can graph our boundary line. We start at negative 4 on our y-axis. All right, and from here, we use our slope. So down 1, right 1. Right, because this is the rise. Since it's negative, we go down 1. And this is the run right here. And since it's positive 1, we go right 1. Or we can go in the reverse order. Go up 1 and left 1. Up 1, left 1. All right, that's another way of doing it. All right, and then do our dash line. And now for the next step, we have to determine the shading. This is a less than symbol. So we're looking for all our y values, right, that are less than our line here. So that's all down here. And that's how we're going to shade. All down here, because that's where it's less than. All right. And then we check for a solution. I'm going to choose to check right here. All right. And it is outside of the shaded region, so I expect that my answer will be false. Remember, this point is 0, 0. So I'm going to plug it right here into this equation. So my x is 0, my y is 0. 0 plus 0, is it less than negative 4? Well, you tell me, is 0 less than negative 4? The answer is no. So this is a false statement, right? And we shade on the other side, which is what we already did. So that's how we know that we shaded correctly. All right, we're done with example 1. All right, let's do example 2. For example 2, we have x minus 2y is greater than or equal to 16. All right, when we look at this, remember the first thing we need to do is to put this equation or inequality into slope-intercept form. First off, recognize without the inequality, this would be x minus 2y is equal to 16. So to turn it into slope-intercept form, the slope is negative a divided by b, right? So that's negative 1 divided by negative 2. And it's negative 1 because remember x is alone, so it's 1. All right, that's our slope. Of course, we don't want a negative in the top and bottom when we can always just write 1 over 2. All right, our y-intercept is c over b. So that's 16 divided by negative 2, which is negative 8. So when we write this in slope-intercept form, it's just, we did divide by a negative. Note that here, which means this inequality symbol is going to change. So when we write it in slope-intercept form, we have y is less than or equal to 1/2 x minus 8. When we graph it, we start at our y-intercept, which is negative 8, just right here. And then we use our slope to do the rest. Also note that because this is less than or equal to, we're going to have a solid line. All right, so from the y-intercept, we go up 1, right 2, up 1, right 2, and we keep this pattern. Or we can go down 1 and left 2 in the reverse order. All right, and now we can just draw our line. It is a solid line. All right, so we've completed steps 1 through 3. Now we have to determine shading. Since we're dealing with less than or equal to, we're going to be shading below. Less than, below. Less than, below. So this is under the line, so that's below. So that's the way we're going to shade. This way. All right. And we're going to do like we did in the other problem. We're going to use 0, 0 to check our solutions. So we're going to plug that into this inequality, or we can plug it into here, either one. Let's do this one. All right, so this becomes 0 is less than or equal to 1/2 times 0 minus 8. All right, do we expect this to be positive? Not positive, true or false? All right, I hope you said we expect it to be false. So is 0 less than or equal to negative 8? This is not a true statement. It's a false statement, which means we shaded in the right way. All right, done with it. Now we're going to example 4. Y is greater than or equal to 4. Remember, y equals 4 goes through the y-axis, which means it's going to be a horizontal line. So 1, 2, 3, 4. This is 4 on the y-axis, and it's going to be a horizontal line going straight through there. No matter what our x value is, y will be 4. And it should be a solid line because of the greater than or equal to. And now it's just about shading. Where are the y values greater than or equal to 4? Well, We already have a solid line to represent the equal to. The greater than is above this line, right? Because this is, for instance, this is y equals 5. So that's above the line. So we're going to shade in that direction. We check our solution. We can use 0, 0. All right, note that this is 0, 0. We can't plug in the x value, so we just use our y value. So is 0 greater than or equal to 4? Nope, false statement. And we did shade in the other direction, so we're done with this. Now, there's one we didn't do. See if you can do it.